Hello friends. So now we are going to start and deploy our first ML pipeline in the Kubeflow environment, basically. And let's make our hands dirty. So let's start with first important thing is you have to go to the AI platform or Vertex AI. Or for my case, I have went to Vertex AI. You can go inside this Vertex AI. Then you have to create your new notebook, Jupyter notebook instance, basically. So if you click on new notebook, you can get n number of environments which you can create. For my case, I'm doing a model training of TensorFlow. So I have chosen this one, TensorFlow Enterprise 2.6 without GPUs, as I'm not doing any image processing kind of thing. But for your case, you can also write your own R program basically to run your model basically. So for PyTorch, for some people PyTorch, for some people Python, they will be creating their model in Python itself. So it depends on use cases. But important thing, you have to create an notebook instance to play around. So I have already created the notebook instance for you guys. And what I have done is that this is there. So then I click on open with a notebook. What happens here is that it will open up a window like this. Now, where you have to go, you have to go to this terminal because terminal will give you a Unix-based environment to run your command. So when you click on this, it will take you to this kind of environment here. So I've already run this one. I'll just go you through. So this is the location where I've maintained my code. So you can see I git clone this one. It's public repository. I'll share it in the description. You can play around and go and play around with the notebooks and all the codes are there basically. So if you go, I just go in here, get it cloned, go to that particular folder, GCP Kubeflow demo, and then you go inside this thing, you open this Kubeflow demo py. This is where I have kept all my commands to get the components created for the KFP and create a Docker file, push it, and then run it as an experiment, basically. Now, I have already done that part for you. I don't want to re-execute the steps. So you can see here, it's going to the farmer location here. In the farmer location, you can see I have got three components: get data, Python file, process data Python file, and train data Python file. These are the three steps. So I have logged into my Docker. For your case, you in a business use case or a production use case, you don't have to always maintain your Docker in the hub repository of Docker. Docker hub repository looks like this. This is my own repository I have created, and I have already published my Docker image here. So I'm just using this image in n number of environments. So I just don't need to create it every time. But you can create it in your own container registry or artifact registry inside the Google platform, which is a private one, and it will be very good use case that will practice this thing without using Docker. You create in your container registry. If you want to go to container registry, go to this one. You will get container registry like this, and then here you can keep all your images. But let's not go in that detail for now, as our main intention is to start a Kubeflow pipeline. Then what I will do is that you will have to write a config file. So I have already written the config file for you. Again, I'll write it for you. So this one is basically consisting of information where my data will get downloaded in this GCS bucket. This GCS bucket, you have to pre-configure it. So I have already pre-configured my GCS bucket and kept it ready so that you don't have to wait for me to create it and then show it to you. So you can just go and play around and create your own GCS bucket and put the information in your config file. So then I just created the config.py here. So you can see the config.py has been created. So I'll just close it for now. And then what happens is you will create the Docker image. The Docker image, which I have kept it here in my this Docker image I created here in this instance. So what it does is basically first installs the dependencies like wget to get the data from any web server source or Python 3 LXML and all those Python GPG agents and get. Say get is what you will require to do. So this kind of stuff you can do. So you just install the dependencies, and this is the key important part. In the image, you should always configure the full cloud SDK, because right now that GS util if you're using or any G-Cloud command if you're using, if you don't have the package installed in your image, then it will fail to execute that particular part. So that is the reason you need to configure that to Google Cloud SDK in your image or pod. So and then you copy this particular scripts, basically all the scripts, get data, process data, and train PY, all the scripts, right? You just copy it into your image so that you don't have to write the code from the scratch. It will be present in your image, and then you can just play around with it. And after that, who run those scripts? I need to do this installation. So basically, I need to update my pip, and I need to install cloud storage pip install. I need to do pip install Google Cloud, GCP, task, and all those things which are using in your pip model. So just to go you through, this is the get data. Basically, this is the Python component which is going to download my file from this location, the URL. Let's see here, this is my source. I'm downloading it into a raw CSV format and storing it into my GCS bucket, which is configured in the config.py. Then I will go to my process data. This is going to do the pre-processing on that download data, and it will do the pre-processing part here. It will process the data and put in a very readable format for what my model will go through and read itself. So, and then this is my train.py. Train.py I already had open. So it will basically consist of the TensorFlow TensorFlow algorithm, basically, which basically performs your tests and performs your validations and all those things, frames, and then keeps a component of accuracy, specificity, sensitivity accordingly. And then you store it somewhere. For my case, I am storing those metadata information for confusion metrics. Confusion metrics, what is confusion metrics? Confusion metrics is like if you have an event, incoming event, it's predicted true or false. If you don't have an event, but still you're predicting true or false. These are kind of permutation combinations happening taking place. So basically, just to give you an overview of it, I already have taken this particular subject. So it's like this kind of confusion metric, like true positive, true negative, false negative kind of scenarios will come up. So these are the kind of combinations which confusion metrics tells you about, but that's not our main motto right now. And then for each prediction or each kind of output of the model, we will give you the kind of accuracy, like what have you trained on and given the prediction correctly with respect to validation data. So that percentage will be calculated, accuracy score, specificity, sensitivity. It will be provided by the Kubeflow package, basically. Kubeflow pipeline will give you this information. You can go through the Kubeflow pipeline, Kubeflow document in Google Cloud documentation. You can understand this particular metrics, what are these metrics and how they are getting populated, basically. But let's stick to our topic. Then this is our Python train.py component. I will not go through this Docker file creation because I've already created it and pushed it to my repository in Docker Hub. For best practice, you do it in content registry as a private repository. But I kept it there because you guys can play around with that Docker image in your own environment. So these are the steps happened basically when I pushed the image. This is the pushing of image. Previously, I built the image. So first step is you have to create the Docker file, then you have to build the Docker file, and then you have to push it to your repository, push it to a private registry. So I'm going to tell you again and again as a production best practice. Then you will install the KFP module. Here I'm installing the KFP module. This is a Kubeflow pipeline module which is going to create the component for you and to create the definition of it. So you can see here, I have already installed it here, and then after it installed, I will import the things which I'm going to use from my KFP module. You can see here. Then I will define my components in that PHP module. So you can see first component I will create like this, define flow pipeline component. So first component is get data. Get data will get the data from that source which I already shown you. Then it will perform. I'll again create another component that is processing, process data pre-processing. This is another component. Again, I'm going to create. Then the third component, the main component, is the train.py function, which I'm going to train my model into data from the data pre-processing step. Now, the point is, here you can see the file outputs. Why I have kept it here as a separate portion, it's because I'll get some log output in my Kubeflow pipeline, but still, I want to get that information properly designating all my accuracy values and all that. And I want to, because you can see here in my train.py, I'm already getting it into a JSON form, right? Why? I want to put it in the log. That is the reason I did it here. Then this one, you can rename it accordingly. This one I'm creating the train.py here. So you can rename this file location or anything. But the important part is this JSON file should this be remain same. This parameter is provided by Kubeflow pipeline, basically. So this ones you cannot change. This one, these two values will remain constant. You cannot change it. These are the kind of metadata values which a Kubeflow pipeline will identify and place it in the log information. And then I have debugged it, the components, if it has uh, competently created those components, and it has. So you can see here this step. It's showing. But I don't worry about the warnings. That's not required for me. And then I create a definition. This is the important part. This is the definition with the pipeline, the sequence. Like first I will do get data. Second I will do process data. Third I will do train data. So these are the three steps. But I cannot do train data first and then get data, then process data. That will be a rubbish thing. So to set the dependency, I'm doing like this. You can see here on the step. This is the way I'm setting my dependency, each one after the other. Now this is the pipeline. But what happens? You can see one magic here. I will create this definition here. Okay, created the definition. I will debug if my definition has been done. So yeah, once I compile my definition, I told you earlier in the theoretical class that when I compile my definition, it will create a zip file. So this zip file will be consisting of a YAML file. YAML file is nothing but a Kubernetes will understand the YAML file to deploy or expose the service or to do any kind of things. Okay, so this will create a YAML configuration file as so that my experiment can run the ML pipeline. So now you will see the magic. You don't see any former Kubeflow SDK demo.zip file, right? So I will create it for you by doing a compilation. So just wait for some time. It will, okay, great. So you can see here, this file has been created again here, but I have been named here. You can rename it as per your wish. Now you just download this one and then open and see the YAML file. So basically it will help you to understand how the Kubernetes is configuring the replication layer, the metadata specific layer, and what kind, it's a service or it's a pod or what it is basically. And then after I've done that, important part, this is one. Now you have created a definition in your notebook instance. How will you get it deployed to the Kubeflow pipeline? Now here comes the next step. Now I have to go to the Kubeflow pipeline. This is my Kubeflow pipeline. How will I get it created instance? Okay, so I will go here. I will not going. I will not do it for now, but I will just show the way how you can create your pipeline instance. So you can see here, I have gone to the AI platform in the pipelines. In the Vertex AI also can go, and you will still see the pipelines there. Here, okay. What you will do, you will create a new instance, Kubeflow pipeline. So for each experiment, for each ML pipeline, you can have your own instance. You can create an automated program, Python or Java or anywhere where you can create the cluster, delete the cluster after training. So like this is a very cool stuff you can also do. So you create the new instance. I'll not create now. It will take a lot of time. I already spent my time on that one. So then click on this one. So you remember what I happened here. This part, where I will, how will I map my definition with the Kubeflow pipeline? This is the key part. So I will get this information from here. Open pipelines dashboard. This will open up endpoint for me where my Kubeflow pipeline is going to run. So this, I don't require the hash tag. I require this particular part, HTTPS until usercontent.com, googleusercontent.com. This one, I'll copy it, place it in my this part. I've already placed it here. I don't want to do it. I'll just configure it. Okay. Now my client has been configured in my KFP. Now I will rename it to Farmer 5. What happens? Farmer 5 is just an experiment name. When you go to the Kubeflow pipeline here, I'll just go here. I'll just close this. You can see I already had run my pipeline. So first 2 times I had failed, but third time I successfully completed, fourth time I successfully completed. So when you go to the experiments, you create your own experiment here from the console. But for now, I will do it programmatically or from Python notebook here. So I will create an experiment. So this experiment is nothing. If you have done this, I have created on this will show you the experiment. Experiment is nothing but to create a logical unit to deploy your ML pipeline. And that is where you can run it multiple times. You can create an experiment, you can run it 1, 2, 3, 4, and 100 number of runs inside that basically. So here I created farmer 5, and then the key important part, I will run my pipeline. This is, still now my pipeline has not run. I have just implemented the definition. Now I need to run it. Now I will click on it. See the magic. Okay, now my instance has triggered the pipeline. Okay, now what's happening? Okay, I hope you remember get data. Get data, what it does, it gets data from the source. Okay, it has completed successfully. That's great. That's great. So I want to see the log. What happens here? It shows data download successfully. I in my Python script, I already mentioned or printed the statement that it should, whenever it successfully completes, it will give me data downloaded successfully. Then it's just data pre-processing to create the features to form, which will be the input for my training model basically. So this one has done. So I don't see any visualization because I don't have any uh, training of, or it doesn't contain any model information here. It's only the data. But when I go to the training, which has completed successfully, you can see a visualization of a confusion metric. This metric got from train.py. Train.py is where you are calculating and doing the calculations and prediction. Okay, this is where the information is coming from. So you can see this is a confusion metric I earlier discussed with you. Like there are combination of event is positive, event is negative, event is false event, and all those combinations. This is the 4 instances, 4 combinations. And most importantly, this is a log, but a very good feature which I earlier showed you, right? This is the information I collected. This is the confusion metrics JSON file which I had incorporated in my train.py. This information, which Kubeflow pipeline documentation can find this kind of values as metadata information, and you can see here beautifully I have placed it in my logs. Earlier it should not have come if I would not have placed that, but as in my Py notebook, you remember in the above step, I have done this part. I'm very sorry for scrolling up and down, but I will just, you can just record the video or play it around to get to the main information. So this is the part, right? I gave that as a file output in my training.py basically. So you can see that is the reason it has come here. Now, after it has completed, so these are the information. So you can see the pipeline metrics are like accuracy is 86%, specificity is 37%, sensitivity is 95%. So this information is getting captured in the log. So these are the kind of things and play around we can do. And this is the way we have successfully completed our pipeline run. Now let's go to the experiments and see the farmer file. Okay, so now a new experiment got created. I can see my pipeline status is executed successfully. Again, I want to see the history of what happened. I can click on it and we can go and check. Now, in the real world scenario, you may come across different concepts like concept drifting, data drifting, overfitting, and those kind of scenarios. So you can create the logic in your component so that it will retrain, redeploy, and do the stuff. And one more point to cover here is that after you have created that one, so this bucket, you remember, this bucket consists of my data. Like this is the location where I downloaded my data. This is the process data where I processed my data location, and then it is the location where I'm keeping my confusion metrics, the output, what I have captured there. And this is a very cool matplotlib part I have implemented here. It's like you can just see I'm just doing model accuracy versus region, that kind of plots I'm putting it here. But you can play around. You can create your own things. You can create a new folder here, model. So you can keep your model inside this folder, and from there you can go to the BigQuery and do the you can deploy that or create a new model on top of this particular model, and then do ML.predictions. And you can play around with your own models for any data. So that's very cool stuff. So get going, and a lot of things to explore in this area. It's just the starting step what I have shown you. It's not at all a very exhaustive one. It's just for you to start from somewhere. I hope I played a part in your journey, and if I am, I'm glad to do so. That's it. Thank you. Bye.